Yeah, as I said, now we're going to cover infrastructure as code, but before, let me introduce myself and give you a bit of background why we need it. So, what's going on? Okay. Cool. My name is Denis Artyuhovich. I'm team lead at The Zone. Originally, I'm from Belarus, now based in London. And at The Zone, we're changing every aspect how fans are engaging with sports, starting from the content distribution to truly immersive experience when in real time you can see like augmented data for the video streams. We are available on more than 200 countries and various types of devices, including smart TVs, tablets, laptops, and of course, like Xbox, PS5, and other game consoles. And I think you can imagine how many types of various infrastructure we have. And my team actually built features which are cross-target. They are available and on web and on TVs. So the answer now probably obvious, but let's consider like normal flow of developing their application. So we're starting with the one feature, or let's say service, then new bright shiny idea comes to the stage and we have one more feature, and then boom, hundreds of them. And in our case, we can expect changes in our infrastructure even multiple times per day. And I think you can imagine how stressy it could be if everything will be manual, because you need to replicate some manual changes. And what if some of the developers forget to update the documentation? Or what if UI itself has changed on our cloud provider, like AWS, and we click on the wrong tick box and Facebook is not available for a few hours? Yeah? So it can be really stressy, right? So to avoid this situation and to fix this problem and never be in such problem, again, we need to take advantage of the infrastructure as code. That's why but before we're going to start talking about the infrastructure itself, let's consider these two programming paradigms, as they are quite relevant when we talk about coding for the infrastructure. On the one hand, we have the imperative, which stands for explicit instructions for literally everything. We usually refer to some bash scripts, and actually, explicit instruction is biggest advantage of such approach, but at the same time, it's the biggest concern because you need to maintain everything yourself, and it's not really scalable over time. On the other hand, we have the declarative approach, which stands to describe outcome and handle the provider to do the rest of the job, which is way easier and better to scale. So yeah, again, with the imperative one, you're kind of smart and you're always blaming system that it doesn't work as you expected because you wrote so many lines of code. When with the declarative one, you just don't care until smart providers are handling everything for you. And the good news that Terraform actually it's an open source. Who worked with Terraform before? Let me ask this question first. Yeah, okay, few people. Awesome. So Terraform is an open source software which is originally developed by HashiCorp, and it supports about thousands of different providers, and it allows us manage our infrastructure with code. And what's more important for today, that it also supports TypeScript, or better to say that CDK, which stands for Cloud Development Kit, supports the TypeScript. And I truly believe that it's a real game changer, because previously, to implement infrastructure, you likely need to learn new language. With the Terraform HashiCorp language, which is not the bad one, it's not the complex, probably slightly more complex than JSON or YAML files, but you know, we are developers. I really like the power of programming languages, and I'm coding for many years, and that's what I would like to create my infrastructure with. And yeah, that's why I think it's a real game changer. So in the next 30 minutes, what we're going to do, I mean, probably a bit less, we're going to build we're going to build a production-ready infrastructure for our React application. To be honest, for even any JS application you choose. And yeah, we're going to do it step by step. It's going to kind of workshop-style talk. You can follow up with the laptops, but don't worry if you need to take your time. After the talk, right at the end, I will share with you all the code samples, and there will be a GitHub repo link, so you can follow up later on. And I'm pretty sure that this talk will be recorded. OK, so we can start. So to start with, let me just do this, because it's a bit it's a bit weird. Cool. Can you see my screen? And just a second, I will make it scalable so I can control it. OK, so I'm really sorry. I just messed things up. But all good now. Cool. Yeah, as a first step, what we're going to do, who used React Create App? I hope everyone, yeah? So we're going to use React Create App just to create the basic TypeScript React application. And we're going to run this command for this. And after this, we're going to have this nice and shiny application ready. But so far, nothing is related to the infrastructure itself. Now, we're going to start with creating some folders for our infrastructure. And as a pre-requirement, we need to install CDK. You can install it on the root level of your machine globally, or you can install it per project. It's your call. But basically, we have, as soon as we have CDK-TF, we can create in our project Terraform folder and start bootstrapping our infrastructure. For this, I'm going to use a command which is CDK-TF init. I'm going to pass the template as a TypeScript, similarly what we've done for the React application, and I'm going to specify local backend. If you know what local backend means in terms of Terraform, that's cool. If not, no worries, we're going to cover it a bit later during the talk. After the initialization, you may see such errors related to the TypeScript, and the reasoning for that, because I'm pretty sure Terraform is going to address them shortly, but so far you need to add skip loop check, because it doesn't really expect that that there will be one more TypeScript project in the same project. So as soon as we add skip loop check flag to tsconfig of the Terraform, everything will be OK. And we're going to able to see that there is a one TS file which is generated for us with a main stack. It's called main.ts. And this file is basically what we're going to use as a starting point and where we start implementing our infrastructure. Of course, because it is TypeScript, later you can create, let's say, source folder, do structuring in a way you prefer, split everything to reusable functions. I'm going to do now everything in the one single file, but later it can be refactored in the way you prefer. Cool. So before we start, we need to add one Terraform providers. As I said, there are 1,000 providers available for you. They are all open source, and you can create your own provider. We're going to use AWS provider, so I'm just adding it to the provider list in the configuration of the cdk-tf.json. And after that, we're ready to crack on. But now we need to define how our infrastructure going to look like, what we actually need for our front-end application. And the first thing which we may need is storage, right? We need to store our application somewhere. I don't know how many of you worked with S3 buckets on AWS, but it's just a simple storage service which has great availability, 99.99%, which is cool. But for us, what's important, we're going to use it to store our static assets, okay? So for this, we can import AWS provider and S3 bucket. That's going to be simplest infrastructure you can imagine, and it's very straightforward. Because it's going to be production-ready one, later I plan to connect some real domain, and that's why I think bucket we can call with a domain name just because it's more explicit. We're going to create the provider. You can use any region you like. I'm going to use US East 1. Just a side note, for your bucket, for example, you can use European region and EU Central 1, whatever. That's absolutely fine. But ACM, which we're going to use for SSL certificates later, requires US East 1 region. It's nothing related to how we're coding infrastructure, it's just related how AWS operates. They need it. It's their requirement. So if you're going to create another region, just create the second one later for ACM. Cool, and we are creating the S3 bucket, passing just now our bucket name, passing the provider. We're telling that it's going to be a website with index.html as a root document, and we also specifying access control list as public read. Because who cares about security, right? I'm making fun, so we're going to fix it later. But for now, let it be public one. So as soon as you made these changes, you just need to build them, and you need to run command yarn scenes to sanitize those changes. So after this, everything will be transpiled. There will be cdk-tf out folder generated, which you can go enter and run commands in the following order. You're going to run Terraform init. You need this command only very first time because we're just starting with the Terraform. After this, you can run a plan. Plan is optional one. It's just to see what will be planned to apply our infrastructure. And after that, you can run apply. And if you do these steps, you're going to see such output in your terminal, which going to tell you what was created. You're going to see even website endpoint. And now we can build our React application with the Yarn build and deploy this React application to the S3 bucket. So actually, deployment part is tricky one. It can be handled with the Terraform when you think it is related to your infrastructure. With the front-end world, I would say that it's not tightly coupled with the infrastructure because you're going to create infrastructure. You don't want to expect changes in your infrastructure all the time when you're updating a version of React or adding new feature. So deployment likely will be separate step in your CI. So I'm going to do it now manually with the AWS S3 sync command. I'm passing the output folder which is built, and I'm passing my S3 bucket name which I just used. And again, I'm specifying ACL as public read. And after this, if you've done it, you will be able to see that your site is available on this URL, bucketname.s3amazonaws.com. And it's awesome. We can start sharing it with our, I don't know, like friends, QAs, POs, whatever. But of course, it's not yet production ready, right? At least we need to connect it with the real domain. So let's celebrate that we have some achievement first. And now let's consider how to connect to the real domain. To connect it to the real domain, we're going to use Route 53, which is DNS service provided by AWS. And now our flow will look like this. So users passing the request, it goes to the AWS infrastructure, which intercepted by Route 53, which is going to alias users to the S3 bucket. So to achieve that, we're going to need to specify just a few changes. We're going to specify Route 53 zone. We're going to create it, and we will use our domain host just because I would like to create infrastructure on the for the subdomain. And I'm going to create a record, which stands for subdomains. And I'm passing my hosted zone, and I'm passing to the configuration our bucket as alias. So it means like everyone who gets access to this record will be transferred, will be aliased to the bucket. So again, we run build since, go to the folder, plan and apply. And now, actually, if we're going to run it, we will see that, let me rewind this. I'm just a bit conscious about time. So we will see that there will be an issue at the very last step. And let's check what actually been created. We're going to go through the AWS console to Route 53. We will see that hosted zone is actually created, and there will be even a record. So what is failed? The thing is, I did it intentionally. I bought the domain with a different provider because I think it's a common use case when you have like domain bought it on different provider rather than AWS. And I need to meet them somehow. So for this purpose, I need to copy NS servers, which are now generated on AWS, and connect them to my domain provider. So my domain provider doesn't have any providers for Terraform, so I'm going to do it manually. You can do it with a Terraform too, but yeah, this is a one-time thing. So my domain provider is in Russia, that's why you see Russian interface, but as soon as we connect it, we need to wait 5-10 minutes till DNS will be updated. And now we run the command with the Terraform apply. And this time, we will see, let me just rewind this a bit. After the validation, which takes, I don't know, like a few minutes max, we will see that everything will be created. Yeah, one resource created, nothing destroyed, nothing changed. And now, if we try to access this domain, we're going to see that it aliases to our S3 bucket, and we can see our website, which is, again, really cool. But it's still unsecure and it's still not production ready, as we're storing our S3 bucket somewhere in the United States, so probably round trip for our customers is going to be like slow, and we need to take advantage of all edge locations, so we likely want to bring some CDN service. We also likely want to bring HTTPS for the secure connection, so let's do these changes. So for these changes, we're going to use CloudFront and ACM. So CloudFront is a CDN service which is available on AWS. When the ACM, it stands for the Certificate Manager. For us, it's interesting that it's going to issue us SSL certificate, which will be associated with our domain. Okay, so let's have a look now. Our infrastructure diagram slightly more complex. So the flow will be now that user starts from the root 53, and instead of go directly to the S3 bucket, it will be redirected to the closed edge location. And our CloudFront will be responsible to retrieve objects from cache for caching, only in cases when cache invalidated, or if it's like very first attempt to access it and there is no cache yet created. Cool, and ACM will be used for the SSL certificate. So we creating the ACM certificate like this using the ACM provider. Again, we're just passing the configuration, specifying wildcard for our domain host, because I would like to use it for all subdomains in the future, not only for one. That's why there is this asterisk sign. I'm going to create the certificate validation record. It's just one more record for our domain, which will be used for validation. And I'm creating the validation itself, passing the ACM certificate and the certificate validation record to it. So again, we need to create CloudFront distribution too, and please don't be scared if there are like you see and think that there are many lines of code. I don't understand them completely. It's actually very straightforward lines when you know like how AWS operates. But if you work with different cloud provider, you're going to learn them from there. If you don't know them, no worries. You go just to the website of the Terraform stands for this provider and gonna read and understand what they stand for. But it's just a configuration final shape of our state which we're trying to achieve. So basically here I'm specifying that default cache behavior will be stands for redirect to HTTPS. We're gonna cover methods get, head, and options because I don't think that we need any post or other methods for our front end. We're gonna set default TTL as a 1 day, and I'm not going to specify any restrictions or any order cache behavior. But if you want to specify order cache behavior, it's exceptions. For example, specific folder you wanna cache only for 5 minutes, or like you don't want to cache index.html at all. You can specify it in the order cache behavior. That's what it stands for. So we're going to pass our certificate, SSL certificate, which we just issued with ACM certificate. And now we need to make the final change in the road 53. Instead of our bucket name, we're going to pass CloudFront distribution domain name. So road 53 won't be redirected to the S3 bucket. Now it's going to redirect to the CloudFront distribution. And we just changing the name and hosted zone. We need to run again yarn build, yarn scenes, go to the CDKTF out folder, run plan and apply. And after apply finished, we're going to see that now we have the secure connection for sure, but moreover, our site is loaded faster. And the reason for that, because now it's available on all edge locations, so we kind of covered the CDN here. And that's super cool. But you remember, like at the beginning, I said that who cares about the security? Now it's time to pay for it, and now it's time to set this up. So now we need to fix our public read ACL, and we're going to use origin access identity for it. So now our infrastructure diagram will be slightly more complex, but this is the final one. This is production ready one. We're going to have route 53 redirecting to edge location as previously. Now we're going to have the CloudFront, which is going to retrieve object for caching. But what's going to change is that this time S3 bucket going to have some specific bucket policies associated with this, and this specific bucket policy is going to check that only specific origin access identity things can have access to it. Okay, so in this case, our CloudFront should have origin access identity associated to get access to the S3 bucket. And of course, after this change, publicly our bucket won't be available anymore. Cool. So to achieve this, what we need to do, we're going to change in a bucket ACL to private. We're going to create origin access identity, and after this, we're specifying the policy document. Again, it's just a configuration which AWS wants us to put. I'm saying here that we want to have access to objects, and we're going to have access to get list of these objects. And as simple as that, then we're just creating the bucket policy, passing the bucket ID and the policy document itself, and associating with the ACM certificate this origin access identity, so our CloudFront gonna have it. Now we can, like, just for simplicity reason, simplest option just to remove everything what we put to our bucket and redeploy it again, not specifying ACL anymore, and use the default one, which is going to be private. And as soon as we've done it, we can check that S3 domain is no longer available. We're going to see this shiny error page provided by AWS by default, saying that access is denied. When CloudFront and Route 53, on the other hand, going to work perfectly fine, and that's exactly what we were trying to achieve. And let me congratulate you, if you're sweating now as I am, I promise you there are no more infrastructure-related things we need to code, but let's discuss a couple of them. We're close to the end of this presentation, but I still want to cover remote backends, because so far, everything what we have done on one machine and locally. And it's not going to work if we start sharing with our teammates, So you may think that we can probably upload our our state, Terraform state, to, I don't know, maybe even GitHub, but it's a bad idea, I promise you, because there will be sensitive information stored. And for this, Terraform has a concept of backends, and those backends, actually, there are plenty of them. You can use different databases, for example, DynamoDB. You can use S3 storage. You can use Terraform Cloud Storage. I don't remember how it's called, but there are plenty of options. I think as we stick with AWS, it makes sense to create our backend on AWS too. And sorry, to clarify, backend is only our output state. It is basically JSON file which provides information about which resources has been created and what's the current state of our infrastructure. Okay, so we're going to create S3 backend. For this, we need to pass a bucket. This actually separate bucket created manually, so you can pass any bucket. Usually in companies you have like some private buckets which are not available anywhere else. And we're going to pass a key. It's our file name, and we're going to pass region, which can be any. So once we've done it, we need to rerun init, and this time when you run it in your terminal, you're going to see that it asks you, do you want to copy existing state to remote backend? And if your answer will be yes, everything will be copied over to the S3 bucket and will be removed from your local machine. Cool. Now let's cover why we use TypeScript. So why to use TypeScript for infrastructure as code? I think, it's pretty cool that there is no new language to learn, even though that I mentioned previously, HashiCorp configuration language is not that bad, but most of us know TypeScript, and why we need to bring anything else. And moreover, TypeScript is for sure way more powerful than HashiCorp configuration language. We have autocomplete, we have typings, we have all mature language advantages, so you can think about like methods you have for array, I don't know, map, reduce, whatever, cycles, like structuring with the different modules. You can't really achieve it with HashiCorp configuration language. You need to store everything in one folder, and there is no clear connection, what is refers to what, and like, in my opinion, it's a complete mess. But now we have more options for code structuring, and we have new ways of sharing. And here I'm talking about, previously we were able to create Terraform modules or plugins separately, but there should be like complete things, and they kind of detached from the front end completely. Now we can use NPM and share our code with the NPM, and we can even implement a test for our infrastructure too. Plus, I just want to highlight, because it's really important, I mean, I tried to make this talk focused for the front-end devs, because I see that many back-end devs knows about the concept of infrastructure as code when it's not exactly so when we're talking about the front-end world. But I think it's pretty relevant for both worlds, not only to create the infrastructure for your application itself, but also infrastructure for your monitoring. For example, you have New Relic and you want to specify some alerting there, or create dashboards, or let's say you have Sentry for this purpose. Again, everything can be managed, and in my opinion, should be managed with infrastructure as code providers. In this case, let it be Terraform. So you can handle incident management with PagerDuty, and again, create the infrastructure for this with a Terraform. So just a side note, it's still like CDK, Terraform itself quite mature already, used in production around the world, but CDK not yet. It's in a beta stage at the moment, so you may expect some changes in the CDK itself, so please be careful about that, and yeah, just it's not going to be fair not to mention this. And now, as I promised, everything, all code samples are available in this repo you can see now on the slide. I tried to follow during commit history in the same way as I presented, so you will be able to follow up among this talk. And thank you so much. That's it. And there is one more repo, Terraform TypeScript front-end infrastructure, which has slightly more advanced structuring and a bit more samples. So if you're interested, you can check it out too. And now I think we have Q&A session if there's still time. Yeah?